Alright, so we're going to look at solving exponential equations, and these exponential equations that we're going to solve here in this in number 52 will be exponential equations in which you can solve by using what's called the one-to-one property. Alright, now to help us understand how the one-to-one property applies with exponential equations, let's look at a very simple problem first of all. If I have 2 to the x power equals 2 to the fifth power, so I have this exponential equation, and notice what makes this an exponential equation is that the variable is in the exponent. Now, one of the other things I want you to notice right away is that the left side and the right side have the same base. Alright, so notice this base is 2 and this base is 2. And if you think about it, if you have 2 to the x power equals 2 to the fifth power, then what do you think x must equal? So remember, the whole idea of solving for an exponential equation is to determine the value of x. So what value of x will make the left side equal the right side? And so if you think about it, well, if the right side is 2 to the fifth, then the left side must be 2 to the fifth as well, right? So x must equal, in this case, x must equal 5. And so the property that we're trying to get at here is that when you have an exponential equation and you are able to get the bases to be the same, then using the one-to-one property, we can then therefore say that the exponents must be equal to each other. And so the one-to-one property that you see most often with exponential equations written as is this. If you have b to the x equals b to the y, so notice I have the bases are the same, they're both base b here. Then according to the one-to-one property, the exponents must be equal to each other. So then we can say that x must equal y. Okay? Now, you cannot, there are some exponential equations, all right, and you're going to see this later on, but there are some exponential equations in which the one-to-one property cannot be applied. And so then you're going to have to use a different method, and we'll get to that point when we get to those set of problems. But for number 52, all these equations that you're going to see, you will be able to use the one-to-one property. So you will be able to get those bases to be equal to each other. So we're going to start out with the first one that's in number 52. So number 52, you have 3 to the, and let's see what it was. Alright, it was 3 to the 4x minus 1 equals 9 to the 4x plus 3. Alright, now, so I have this exponential equations, and I want to solve for the variable x. I want to find out what value of x will make 3 to that expression equal 9 to that expression. Okay? Now be a little bit careful. You don't want to automatically use that one-to-one property. You don't want to automatically say that 4x minus 1 equals 4x plus 3. All right, you got to remember that in order to use that one-to-one property, those bases must be the same. So notice this base here is 3, this base here is 9, so they're not the same. But remember, these problems that are in number 52 are problems in which you can get the bases to be the same. So let's think about 3 and 9. So let's compare those bases. All right, so you always want to compare the bases. You want the bases, if possible, you want the bases to be equal to each other. So I have this base being 3 and then this base here being 9. And so you want to think about these two numbers here. And you want to try and get these bases to both be the same. Well, 3 is a prime number, so you can't do much with 3, right? But let's look at 9. How can I write 9 using 3? So remember, 9 is 3 to the second power, right? So that's what you're going to do. So what you're now going to do is you're going to replace 9 with 3 to the second power. So this becomes 3 to the 4x minus 1 equals 3 squared. So you see 9 is 3 squared. All right, now make sure you put that in parentheses. It's very important that you put that in parentheses. So 9 is 3 squared, but remember this 9 here, remember 9 is 3 squared, so this 9 is being raised to the 4x plus 3 power. So don't forget that. All right, now what you want to do next is to get rid of these parentheses uh, that you just put in here. So you got to use another property. So remember that the power to a power rule that you learned in a previous course. Power to a, well, let me write it like this. Power to a power rule. All right, and so basically, if you remember the power to a power rule, it says that if you have, I'm going to use a simple example that you can actually understand. If you have 2 to the third power, and that's being squared, all right, so you see I have a power is the power, then that expression here is the same thing as saying 2 to the sixth power. So remember, 2 to the third squared means 2 to the third twice, times itself twice. So 2 to the third times 2 to the third. And remember, when you multiply like bases, you add exponents. 3 plus 3 is 6. So you see you get 2 to the 6. But remember, another thing you learned about this, to get that 6, all you had to do is multiply those exponents. All right, so the property you learned, if you can rewrite it like this now, let's say we had b to the x raised to the y power. So when you have a power raised to power, you multiply those exponents, you multiply those powers. So this becomes b to the x times y. So now using this idea with this 4x plus 3 expression has to be multiplied by 2. All right, so then what you're going to do now is you're going to rewrite it like this. All right, so now be careful. You're gonna rewrite this right hand side as this. You're gonna say 3 to the and the exponent is gonna be 2 times 4x plus 3. So make sure you understand that 4x plus 3 is being multiplied by 2. So some students mess up and they'll say 2 times 4x is 8x and then say 8x plus 3 and forget about the fact that this 3 also has to be multiplied by 2. So that's why it's important to think of it like this. Now using distributive property, I get 3 to the 4x minus 1 equals 3, and then 2 times 4x is 8x, and then 2 times 3 is 6. Okay? Now we can use the one-to-one property. So now we have the bases are equal to each other. The bases are the same. So according to the one-to-one property, then the exponents must be equal to each other. So you're going to say 4x minus 1 is going to equal 8x plus 6. So notice that to solve this exponential equation had earlier, in which the bases were not the same, I rewrote the bases so that they were then the same. And then I used a one-to-one property. So you said those exponents equal each other, and that's where we are. So now we're going to solve this linear equation. So to solve this exponential equation using a one-to-one property, I'm going to end up solving a linear equation. And so subtracting 4x from both sides, I get, this is 0, I get negative 1 is equal to 4x plus 6. Subtract 6, I get negative 7 equals 4x. And then dividing both sides by 4, the value of x is going to be negative 7 fourths. And so there's your solution. So when x is negative 7 fourths right here, and you can check if you want to check it, let's just check it. Now on a test, you're not going to have time to check these, but in terms of homework, you can easily check those. So let's check to verify that negative 7 fourths is a solution. All right, so we have, always go back to the original problem. We have 3 to the 4 times negative 7 fourths minus 1 equals 9 to the 4 times negative 7 fourths plus 3. Okay, and so here we have 4 times negative 7 fourths is a negative 7, so this becomes 3 to the negative 7 minus 1, and negative 7 and negative 1 is a negative 8, so this is 3 to the negative 8, right? Over here, 4 times negative 7 fourths is negative 7, so this right here becomes 9 to the negative 7 plus 3, and negative 7 plus 3 is negative 4, so that becomes 9 to the negative 4th power. And now remember, you might say, well, I still don't know if those are equal to each other. Yeah, you do. Remember 9 is 3 squared, right? So I'm going to replace 9 with 3 squared. So I get 3 squared raised to negative 4. And then when you have a power raised to power, you multiply those exponents. So 2 times negative 4 is negative 8. And notice those are equal to each other. Okay? And so that's how you would check this. All right. But remember on a test, you're not going to have time, especially in a time test, you're not going to have time to check all of these solutions. So that's why you want to make sure that as you go through the process of solving, that everything you do is mathematically correct. All right, so that was letter A. All right, so let's look at letter B now. So in letter B, we have this problem. All right, so this is B. We have 4 to the x plus 3 equal 16 to the x minus 3. All right, so just like the previous problem, um, you want to try and get those bases to be the same. All right, and once you get those bases to be the same, then you're going to use that one-to-one property, and you're going to set those exponents equal to each other. Now, don't set them equal to each other just yet because the bases are not the same. This one's 4, this one's 16. So what you want to do now is to compare the bases. See if you can get the bases to be equal to each other. All right, so let's compare the bases. So let's see if we can rewrite 4 and 16 so that way they have the same base. Okay. All right. Now, there are several approaches you can take here. For instance, we all know that 16 is 4 squared, right? You agree? And this is 4, and 4 is the same thing as itself. So if I want to, then I can get the base to be the same here by rewriting 16 as 4 squared. And that will work. What I want you to notice though is this. Someone else could have said, well, I know that 4 is 2 squared, and I know that 16 is 2 to the 4th power. So someone may say, well, can I get the bases be 2? Yes, you can. You definitely can. And we'll do both of them just to show you what it's going to look like. But chances are, most of you are going to recognize, hey, this is 4, this is 16, and I know that 16 is 4 squared. And you're going to go with that. And you're going to, a few of you may go with trying to get the bases to be 2. But those are the only ones that will work. You can't use any other base here. No other base will work. So the only bases that will work here would be either getting the bases to be 4 or getting the bases to be 2. Okay? All right. So let's go ahead and do the bases to be 4. So this becomes 4 to the x plus 3 equals 4 squared, just like the previous problem. So make sure you put that in parentheses, to the x minus 3. Then using a power to a power rule, make sure you rewrite this, we get 4 to the x plus 3 equals 4, and you're going to rewrite it just like this. You're going to say 2 times x minus 3, just like that. Now, using the distributive property, see the base is now the same. Using distributive property, I can rewrite this exponent as this, 4 to the 2x minus 6. Now I'm going to use the one-to-one property. So now I have an exponential equation where the bases are equal to each other, so therefore the exponents must be equal to each other. So you're going to say x plus 3 equals 2x minus 6. So notice I have a linear equation that I am going to be solving for. All right, so that's how easy this is. Okay, so let's solve this linear equation. I'm going to subtract x from both sides. So I get, this is 0, so I get 3 equals, and then 2x minus x is x minus 6. Adding 6 to both sides, I get, x equal 9. And there's your solution. X is 9. And just like in the previous problem, you can check this, and let's go ahead and do that just to show you how to do that again. So we're going to check x equal 9. I'm not going to do it for the remaining problems. I'll just do it for A and B. But if you check your solution, you get 4. Remember, always go back to the original problem. So here's my original problem. And so in place of x, I'll substitute 9. 9 plus 3, right? So you get 4 to the 9 plus 3, which is 4 to the, what, 12th power? And over here, this becomes 16 to the 9 minus 3, which is 16 to the, and 9 minus 3 is 6. All right, you may say, well, just like you did in the previous problem, you say, well, I still don't know if those are equal. Well, you could, if you, and you have access to a calculator, you could, and I'm trying to find my calculator, you could use your calculator to see if those are equal to each other, but you can also just real quickly remember that 16 is 4 squared, so 4 squared to the 6, and then 2 times 6 is 12. So this is 4 to the 12th, which is what this is. But you could use your calculator, and I can't find my calculator. So, oh, here it is. So you could have easily said this. You could say, well, and you got to be careful sometimes because 4 to the 12th may be maybe too big. Sometimes these numbers here, these, see, 4 to the 12th power is going to be a huge integer. Well, it's not going to be that bad. So as long as you can remember these digits, so 1677216, right? And then 16 to the 6 should be the same. And so you get the same thing. Okay, so you could do it that way as well. All right, now someone else. Remember earlier we said someone could have said, well, I'm going to get those bases to be 2's instead, and that's fine. So let me kind of show you what that would have looked like. So I'm going to go ahead and do it right here. So that would have been this. So I'm going to go ahead and rewrite the problem, the original problem, and we're going to use base 2. So 4 is 2 squared, right? And so you get 2 squared, which is 4, but don't forget your exponent. And then 16 is 2 to the 4th, and again, don't forget your exponent. And then we're going to use the power to a power rule on both sides. So this becomes 2 to the 2 times x plus 3. See, 2 times x plus 3 equals 2, and then 4 times x minus 3. Just like this. And now the base are the same, so you can set the exponents equal to each other. So you get 2 times x plus 3 equals 4 times x minus 3, and you're going to solve these linear equations. So distributing, this becomes 2x plus 6. Over here, this becomes 4x minus 12. All right, let's go ahead and subtract 2x on both sides. And so I get 6 equal, and then 4x minus 2x is 2x minus 12. Adding 12 to both sides. 6 plus 12 is 18. And so I get 18 equals, this is 0, and I get 2x. And I'm going to have to do this here. So 18 equals 2x. So that means x, when you divide both sides by 2, you get 18 divided by 2, which is 9, which is what we had here. Okay, so that was letter B. All right, let's look at C. All right, in letter C, you have this problem. You have 8 to the x plus 5 equals 16 to the 2x plus 3. Okay, all right, now, so remember, these set of problems, you want to use that one-to-one property. So in these set of problems, you're going to be able to get those bases to be the same. So let's think about 8 and 16. Now remember, you want to rewrite 8 and 16 as a integer raised to a power. Now be careful, some students are going to say, well, I'm going to rewrite 16 as 4 squared, and then someone else is going to say, I'm going to rewrite 8, but remember, you got your exponents here will have to be integers. So if you put this as 4 squared, which is what 16 is, then you want to rewrite 8 as 4 to an integer power. And so if you think about it, 4 to an integer power is and you're going to probably want this to be a positive integer. So 4 to the first power is 4, 4 to the second power is 16. So there's no way you'll be able to get the bases to be 4. This is basically what I'm saying here. So you got to try something else. So let's think about another base, maybe 2, right? So if I rewrite 8 as 2 to the third power, which is what 8 is, and 16 we know is 2 to the fourth power. And so therefore, I can rewrite 8 and 16 using base 2. And so that's what we're going to use. So I'm going to go here, I'm going to rewrite 8 as 2 to the third, and don't forget that's being raised to the x plus 5 power, equal, I'm going to rewrite 16 as 2 to the fourth power, don't forget, write it like this in parentheses, and that's being raised to the 2x plus 3 power. And now we're going to use the power to a power rule on both sides. And remember how you're going to write this. You're going to say 2 to the 3 times x plus 5, and then 2 to the 4 times 2x plus 3. Okay? And now I have the bases are the same, so therefore those exponents must be equal to each other. So you can set those exponents equal to each other now, or you can distribute first and then set them equal to each other. Does not matter. I think in the previous problem, let me go back to the previous problem and see what we used here. So what we did in the previous problem was we just went ahead and set those exponents equal to each other, and then we distributed. So if we're gonna be consistent, we'll just do that here. So we're gonna say 3 times x plus 5 must equal 4 times 2x plus 3. And then we're going to solve this linear equation. So I'm going to use a distributive property. So I get 3x plus 15 equal, and this is going to be 8x plus 12. And then let's go ahead and subtract 3x on both sides. 3x minus 3x is 0, and 0 plus 15 is 15. And then 8x minus 3x is 5x, and then plus 12. And then subtracting 12 from both sides, I get 15 minus 12 is 3, so I get 3 equals 5x. And then, see that's 0 here, and then dividing both sides by 5, I get my solution. So my solution is going to be 3/5. Alright, so that was letter C. Alright, not that difficult, fairly simple to do. Alright, and let's look at D. So D, we have this problem. And let me just write it first. So we have 1/3 to the x plus 4 power equal 27 to the 2x minus 1 power. Alright, so this looks different than A, B, and C, right? Because if you look at A, B, and C, the original problem, the basis was an integer. In this case, a positive integer. So remember, the base can never be negative. But the base was a positive integer, right? And in each of those cases, in A, B, and C. But when I come here, this base is a positive integer, but 1/3 is not an integer. 1/3 is a rational expression. And I'm going to say 27 is a rational expression too, but 1/3 is not an integer to begin with. All right, so let's think about this though. One of the properties you learned in a previous course was where you had, and I'm going to say this, you have a negative exponent rule. Negative exponent rule. Okay? And what the negative exponent rule, if you remember, looked like this. So let's say we had 2 to the negative third power. So 2 to the negative third power, remember you want to try and get that exponent positive. So the negative exponent rule allowed you to rewrite this expression using a positive exponent. And 2 to the negative third is equivalent to 1 over 2 to the positive third, which becomes 1 divided by 8. All right, and so if you remember that negative exponent rule, it basically said this: if you have, I'm going to write it like this: b to the negative n power, where you had the negative exponent, that is equivalent to saying 1 over b to the n power. Okay, and so we can go a little bit further with this. So let's say I had 3 to the negative 1 power, right? So according to this idea here, 3 to the negative 1 is the same as 1 divided by 3. Well, look at this right here, 1 divided by 3. So 1 divided by 3 is 3 to the negative 1, isn't it? I can rewrite 1/3 as 3 to the negative 1. Well, isn't that what we have here? 1/3. So according to that negative exponent rule, that 1/3 is equivalent to 3 to the negative 1 power. All right, and so it's kind of like saying this. So let's say I had 1 divided by 4 to the negative 5th power right here. I'm sorry. Let's write it as 1 divided by 4 to the fifth. So 1 divided by 4 to the fifth. According to the negative exponent rule, that's the same thing as saying 4 to the negative fifth. So 4 to the negative fifth is equivalent to 1 over 4 to the fifth. All right? And so now what we have here is this. I have 3 to the negative 1 is equivalent to 1/3, but don't forget that's being raised to the x plus 3. And now you want to think about 27. Is there any way I can write 27 using this base 3 that I see here? See this 3 right here? Well, remember 27 is 3 to the third power. 3 times 3 is 9, 9 times 3 is 27. And so I'm going to rewrite 27 as 3 to the third. So 3 to the third, parentheses, 2x minus 1. And now I'm going to go back. I'm going to use the power to a power rule just like I did in the previous 3 problems. And so this becomes 3 to the negative 1 times x plus 3 equals 3 to the, and then remember your base is 3 here. You're going to multiply these powers. You're going to say 3, this is 3, times 2x minus 1. Okay? And now we're going to, now that you have the bases equal to each other, that one-to-one property says those exponents must be equal to each other. So negative 1 times x plus 3 must equal 3 times 2x minus 1. And then using distributive property, negative 1 times x is negative x. And then negative 1 times 3 is a negative 3 equal, and this is 6x minus 3. And then subtracting or adding x to both sides, I get x and a negative x is 0, so I get 0 and negative 3 is negative 3, equal 6x plus x is 7x minus 3. Adding 3 to both sides, I get negative 3 and 3 is 0, equals 7x, right? And then dividing both sides by 7, I get my solution is 0 divided by 7, which we all know is 0. So there's your solution. Don't leave it as 0 divided by 7. You need to remember that 0 divided by 7 is the same thing as 0. So there's your solution, 0. All right. So in this problem is different in the fact that now we have this original base here that's a fraction versus a positive integer. And so you're going to have to rewrite this fraction using the ideas of negative exponents. So that's it. So that is solving exponential equation using one-to-one property. All right.